In this video, I'm going to go over the remainder theorem. What is the remainder theorem? Well, it's written in green right over here. We're talking about dividing polynomials. So if the divisor, d of x, is x minus k, k could be anything, 2, 3, 17, then f of x equals x minus k times q of x plus r. What does that mean? X minus k is what we're dividing f of x by, right? So we've taken f of x, we've divided it by x minus k, and we get our quotient. That's why we use a q here, quotient in terms of x, plus the remainder. Okay? Now, to evaluate x equals k, which we substitute in for x, so f of k, when we substitute that k in for x, look what happens. K minus k times q of k plus r. R is the remainder, so there is no k in there, so it doesn't change when we substitute k in for x, right? K minus k is 0, and 0 times anything is 0. So 0 plus r is just r. So f evaluated at x equals k is just the remainder. Now, if you understood that, then maybe you don't need to watch the rest of this video. But on the off chance you didn't, which is most of us, I'm going to explain it by working an example. Now, we've seen problems like this before, maybe, right? Evaluate f of x, which is this whole long thing, 6x to the fourth minus x cubed minus 15x squared plus 2x minus 7, right? At x equals 2. That's pretty simple, right? You just do f of 2. Right? You do 6 and you substitute that 2 in for x. Now, before I get into the remainder theorem, let's actually evaluate this out and see what the answer is. 2 to the fourth is what? It's 2 times 2 times 2 times 2, right? That's 16. So 16 times 6. 2 to the third. 2 times 2 times 2 is 8. Minus 15 times 4. Plus 2 times 2 is 4. Minus 7. Okay. Let's assume that you do not have a calculator and do 16 times 6. Quick review. 6 times 6, 36. 6 times 1 is 6 plus 3 is 9. So 96. What is it? Let's actually evaluate some things here. Negative 8 plus 4. Negative 4. It's 15 times 4. 5 times 4 is 20, right? 4 plus 2, 6, so 60. Minus 7. All right. 96 minus 60, because we can do this in whatever order we want. 96 minus 60 is 36. Minus negative 4 minus 11 is 11. Or minus 7 is 11. So 36 minus 11 is 25. So that is the answer. All right. I'm going to show you another way to get that same answer using the remainder theorem. Let me just erase this. All that hard work. Now, using the remainder theorem, we can skip all that, but it still takes a bit of work. We take 6x to the fourth minus x squared minus 15x squared plus 2x minus 7. and we use this remainder theorem. How do we do that? Well, we take f of x and we divide it by x minus k so that we can get the remainder. Doesn't really matter what the quotient is, just so long as it's correct, we'll get the remainder. And the remainder should be 25. So what is x minus k? X minus the k in this case is the value for x that we want to evaluate at. So we're dividing f of x divided by x minus 2, right? All right, so polynomial division. X goes into 6x to the fourth. How many times? 6x cubed times. So we get 6x to the fourth. Negative 2 times 6. Negative 12x cubed. That's a cubed. I didn't write that down correctly. It happens. All right. Change the signs. This becomes 0. And that's just 11x cubed. Bring down the minus 15x squared. And what do we multiply by x to get that? 11x squared. Gives us 11x cubed. Negative 2 times 11, negative 22x squared. Change the signs. That gives us 0 here again. And what do we get here? 7x squared. All right, bring the 2x down. 7x goes into 7x squared. Negative 2 times 7 is negative 14x. Change the signs. We get 0. 16x, right? Bring down the negative 7. X goes into 16x how many times? 16 times. Negative 2 times 16 is minus 32. 32 minus 7, 25. And that's our remainder, right? So what we did is we checked our answer before we did it. Kind of interesting.